Most of us start out with good intentions when it comes to building larger factories. The problem is, without the right planning, the build either fizzles out of energy or you find yourself ducking and weaving between factory lines as it slowly turns into a chaotic mess. Thankfully, after thousands of hours in the game, I've picked up a few tips for planning out factories. So today we're delving deep into making the perfect plan, so that you can realize the build you've always wanted. Starting with planning the resources needed with the end item in mind, various tools available that can streamline your process, finding the perfect spot for your facility, and how to use blocking to help with efficient logistics. As well as going over a ton of tips and tricks that'll save you time and effort, and we'll do this whilst building our own director assembly line so you can see the whole process in action. Now, this is a continuation of our guided playthrough where I cover everything that you need to know to get through the game. So let's cover quickly what happened in the last episode, where we built this plastic facility using recycled alt recipes to produce 900 plastic per minute from 300 crude oil, which we'll be using most of in today's build. We also set up this super quick and easy one blueprint railway to connect this facility to our main base and increase the power by 10 gigawatts, ready for today's build. Now, if you do want to check out that video, I'll put a link in the description below, or you can find it in the guided playthroughs playlist. Now, as we are going to go in depth with this video, it will be quite long, but I highly recommend watching through the whole process as I'll be sharing tips throughout. But let's go over the main talking points of today's video. So starting off, we'll look at how to start planning a facility, followed by tools to make this easier, how to optimize the build, how to pick the perfect location, how to plan around resource availability, area logistics, scalability, design versus functionality when planning, build prep, factory blocking, compartmentalizing to reduce burnout, avoiding unwanted spaghetti, efficient blueprints, power planning, failsafes, and finally the layout for today's build. Now, we've got a lot to cover, so let's not waste any time and get into it. Now, here we are at our old factory, the factory from last week, and we're going to be using these resources. We know we will be using a lot of this plastic to produce what we have planned today. And what we need to produce is the assembly director systems. And for this, we need to produce the adaptive control units and also supercomputers. So this is going to end up being quite a big build, probably the biggest one that we've done in this series so far. But when planning a factory, regardless of what it is, it's really important to start off with the end item in mind. From here, we can work out how much of each item we need. So for one of these, we're going to need 1 supercomputer per minute and 2 assembly director systems. And we can either work our way back through the production chain using a notepad and pen. So from here, knowing that we need 2 of these per minute, we know we'd have to double this. And so that would give us 10 automated wiring per minute, 10 circuit boards, 2 heavy modular frames, 4 computers. It can be really beneficial to use something like an Excel spreadsheet, but I'm quite lazy, so I tend to use tools, and we will talk about some tools to use to make it all much easier for you shortly. But before we do that, you're probably wondering another grand question, which is, how do you know how much to produce? It really comes down to what item you're producing and how much you're going to be using it. So for example, if we're doing a factory and we're going to be using a lot of the alclad aluminum sheets to produce the conveyor belts, then for an alclad aluminum sheet factory, you're probably going to want to produce quite a lot. You can go through them quite quickly. For them, maybe a couple of 100 items per minute will suffice. However, with things like space elevator parts or even the later tier items, so for example, supercomputers, you're going to need a few for the Mark III miners, but not a huge amount. As such, we can probably get away with just doing a handful a minute, maybe 1 or 2. And with the assembly director system, I think we're going to produce, it's 75 per minute. I think we'll try and do 1.5 per minute, so that would be 2 assemblers. And to plan this out, we're going to be using a tool that I find particularly beneficial. Now, there are other tools available which we'll talk over just briefly that you can look into, but for me it's Satisfactory Tools. Satisfactory Tools is one of several resources that you can use to plan out a factory, and you can see I've used it a lot for my other builds. So if we click here, this is a tab which covers what I'm doing in my main Let's Play at the moment, and I've also worked out roughly what we're going to be doing today, but we're going to optimize this system shortly. But the way this works is once you go to satisfactorytools.com, you can click on the calculator setting, and then from here you can pick an item to produce. We can click this, and then we can choose how many we want to produce per minute. So I want to produce 2. We know that we need 1.67 manufacturers, and we can actually look down the whole production tree to see exactly how many raw resources we need. In this case, it already has chosen to use SAM ore. If you don't want to use that, we can go to the items and inputs and we can disable SAM, and this will only use now the vanilla recipes to produce this. If we wanted, we could also add, say, in this facility, we've got plastic, so let's add 900 plastic, which it has available. And we can click off the crude oil because I don't think we need the oil for anything else. And from here, you can see how much we are using of the plastic to produce those 2 supercomputers. On the flip side, we could go up to here and maximize based on the resources that we have selected. So here with 900 plastic, we can produce a total of 5.357 supercomputers per minute using the vanilla recipes. So this can be really beneficial when planning out a factory. And we'll actually go over the assembly director system in a moment. But before that, let's cover some other tools that you can use. So outside of Satisfactory Tools, there is Daniel's Satisfactory Tools. This can be found through Reddit, but I'll put all the links to the tools in the description below. And from here, it works just like the other calculator. You can pick the particular item, and here you go. You can see what you need in order to produce that. There's also the production planner on the Satisfactory calculator. From here, you can add an item and then add the amount that you need, and here it comes up with the layout, and you can also break it down as you can see here as well. The other option, if you go over to Steam, this has been widely appreciated by a lot of the community, and it's called the Satisfactory Modeler. And by no means is this list exhaustive. There are many other planners. There are people with Excel sheets that you can use as well. It's just finding something that you find useful that's going to cut down the amount of work that you need to put in order to create these builds. Okay, so now we're going to look over the build that we've selected. Now I've chosen to go with 1.5 assembly director systems per minute because we're going to just leave that to run whilst we're doing the production of the other space elevator parts. I want 2 supercomputers per minute because we're just going to put them into storage, and they're going to be used for the Mark III miners as well as other buildables, and then also 10 computers per minute just to increase the amount of computers that we have coming in. And this has given us a wonderful tree of production, which we can move about to clearly see what it is that we need to produce and where. The problem is with this recipe as it currently stands, we're using SAM, we've also got crude oil being used as well, and we're using a lot of copper. 1,800 per minute and even 787.5 iron, which is a bit annoying because a Mark V line is 780. So what I'm going to do now is optimize this build first and foremost based on the alternate recipes that we already have access to. So I'm looking through my hard drive library of all the hard drives that we have unlocked since starting, and there are a few recipes here that might be really useful to us, such as coated iron plate. We could go with Caterium computers, but I don't really want to produce rubber for this build, so we probably won't use it for this one, but steel screws might be useful. There's also the Caterium circuit boards, which would use plastic and quick wire. And we do have Caterium nearby. We'll talk about picking the right spot shortly, but we're going to go through the recipes that we have available to us currently and see if we can reduce the amount of buildables, the amount of resources, or even power that's required to build this, just to make it simpler for us. We're going to start off by going to items and inputs. Now, as soon as I click SAM, I know that this is going to say that it can't be calculated. Oh no, sorry, if I click off crude oil, this is because given the inputs, it can't be made without producing consuming crude oil to produce plastic. Thankfully, we've already done the plastic, and I know that we're producing 900 per minute, and we can have that added in, and it still can't be calculated. So we're going to go through the different recipes that we have access to now and try and find a way to reduce the build. Actually, before we do that, let me just very quickly select these so that we can compare. You can see that we'll need 170 constructors and 48 assemblers, as well as 22 manufacturers, 14 refineries, and 70 smelters. That's 337 buildables, excluding these two. So we want to reduce that, and we'll see what we can do. So let's go back to the items and inputs. Let's remove the crude oil, let's remove the SAM, and now we'll go to the recipes. Now, I've already mentioned that we have some potential recipes that we can use. So for example, there's Caterium circuit board. And whilst I select these items, I'm also going to remove them from the base recipes, just in case they accidentally choose to go with the vanilla recipe for whatever reason. Do we have Caterium wire? No, we don't want this one. We want, I think it was the fused wire that I was looking at. We do have access to coated iron plate, so let's grab that one anyway, because that will reduce the amount of iron that we need. There was also the fused quick wire, so this will combine copper, so it's going to increase the amount of copper that we need, but it's going to make our Caterium go further, so this is going to be really beneficial to us. And then we also have access to the plastic AI limiter. So if we now go back to production, you can see that our iron ore is down to 652, which is fantastic. And we're currently using 324 Caterium ore. This isn't good because from what I remember, we only have a normal Caterium node nearby, which means with a Mark II, we can only get 300 ore per minute. So we're going to have to reduce this, but have no worries. I'm sure we'll be able to. I think we've got a high-speed connector recipe as well. So let's go to silicon high-speed connector. This will require us to bring in some silicon or quartz, but it's actually reduced the amount of Caterium that we need. So that was definitely a good choice for us. And what we can do to ensure that we don't use too much of a given resource, we can cap it. So here we're capping Caterium to 300 per minute to ensure that it will come up as it can't be calculated if we're using recipes that increase that. If we look here, is there anything else that we have access to? So we have steeled frame, which I think could be useful. Cast screws would reduce the amount of constructors that we need, but if we have steel screws, that could be really beneficial. So let's jump back over and do those two recipes. And from here, we've got the steel ingots, we've got the steel screws being produced, and then the modular. That's not the right recipe. So let's remove modular frames because we've selected the steel frames. And if we go back to this, we're going to be using 356 Caterium, just under 800 plastic, 1000 copper, 270 limestone, 449 coal, and 479 iron. I'm pretty happy with that. We have reduced our buildings needed by over 100. So that is going to save us a lot of space. And speaking of space, we can now move over to the next part of this build, which is picking the right location for this. So these are the 6 resources that we need to collect. Now I should preface this and say that we already know that for this build we're going to be building by the plastic facility, but the reason that we chose this is because we have the limestone, a ton of copper, iron, caterium, as well as coal and some quartz, which we're actually not using, nearby. However, if I didn't know how good this particular spot was for the build, I would go either scouting, looking for an area which had all those resources available, or what would be easier is to head back over to Satisfactory Calculator. They actually have the interactive map. So from here, we can go to resource nodes and we can select all of the resources that we want to have shown on the world grid. And from here, we can see potential areas that would be useful. But we have, in this circumstance, obviously our plastic being produced here and all the rest of the resources easily available to us. The other option would be maybe we could build over here. We have the coal, limestone, caterium, iron, and then the copper nearby, as well as the raw quartz. But we don't have any plastic here, so we'd either have to ship the plastic to us or look for a oil node, which of course there are some here. And so by looking through the map, we can get a good idea of places where it might work for our build. And then based on if you have a factory nearby and it's easy to get there, then that might be the perfect option for you. You don't really want to be going the opposite side of the world if you don't have a good dimensional depot system, because you're going to have to be going back and forth to collect those resources in order to build, which is why for us, having our main factory in the rocky desert and our next factory in the biome next door to it is going to work pretty well. So now that we know where we want to build, we have to check the viability of the build based on how we're going to get the resources to us. So we're talking logistics. For us, in this circumstance, we have a platform here that's suitable for our trains, and we have all the resources nearby to the train line. So we could collect all of the resources and have them sent to this specific station. And with the plastic already here, that would be all that we need in order to build this facility. If it weren't for us already having this train line built, then we'd have to think about how we'd bring the resources over to here. And it's quite a long distance for a bus, for example, taking the caterium from here all the way up to this facility. So maybe that wouldn't work for us. Or same with the coal and the quartz. It's these things that you have to think about. How are you going to get the resources to your factory before you even start building it? In this playthrough, I'm really about functionality and producing the resources that we need. So we do have these open-aired factories. However, in my Let's Play, I'm more interested in the architecture and building factories around decoration in mind. The problem with building with architecture in mind is that quite often you find that you want to focus on the design of the building, and then you have to fit the facility inside that. For example, in this section, I wanted one long row of refineries for the concrete. But unfortunately, I wasn't able to fit them all in this area as I planned. So we've actually separated it into, well, 3 sections because we also have these here. As such, when it comes to planning, I highly recommend building function first and then decorating around it. Now we're almost ready to start building, but before we do, there's one thing that you want to consider, which is also the space around your build. You will almost always need more space than you think you need. So we're probably going to end up, I think, building actually over in the water here. That's just going to mean that we've got a lot of space to build. We don't need to worry about bumping into the cliff sides or various rocks and coral which are in the water there. And so this should be quite a simple build for us. But you also want to consider whether you'll want to scale this system up later. But for that, you want to make sure that you have plenty of space available. So you now have the perfect plan for building your factory. But wait, there's more. So the next thing that you need to consider before you start placing down your foundations is where all your resources are going to come from. Yes, we said in our case we're going to bring them in via the train, but if we're bringing them over to this area here, oh dear. Cut! So if you're bringing the resources over to this location, where are your inputs going to be? Where do you want the outputs? So I'm going to be bringing all of my raw resources from this station here, and I'm going to have to extend this station because we've got at least, I think, 6 stations worth of resources coming in. And then we're going to run a bus down this side over to here. And then I'm also going to bring the plastic along to this location as well. From the left of the build, we're going to run the resources down to the right, producing what we need, and then probably over this area, we'll have the finished product. Another thing to bear in mind, and I'm going to demonstrate this, looking back at the Satisfactory calculator and building out the train station here. And I think we said we needed 6 crates. So 1, 2, 3, 4, 5. So we have our 6 stations here. If we jump over to the calculator again, we can see we need 260 Caterium. But if we quickly work out roughly where everything connects together, we can get an idea as to roughly how we want the resources to come into this build. So our train station should probably be raw quartz, Caterium, and then 2 copper stations, iron, coal, and limestone. And we would want the resources to come into the station in that order. That way we don't have to have the lines going like ducking under or over one another. We can just separate them into their own bus line, run them all in order, and then they'll be able to go to the right down the facility without having to cross each other that much. So that is something really useful to think of when getting started. So what I'm going to do now is to grab all of the resources, and I'm going to get them to this train station, and from there I will bus them all the way to the start of the build, and then we're going to actually start planning out the foundations that we need, and we'll talk about blocking and move forward with the build from there. We've now sorted out the logistics, so I've kept it open for the time being. I'll decorate this later, but you can see we've placed the train station just on the edge where the concrete is, well, limestone is, and that's being sent back round onto the rail so that it can head to the facility. Both the concrete and the raw quartz is being sent up the supports and through to the station to be collected. And the Caterium is just running across a very basic bus, which I will decorate later, to the train station, with all the others directly being fed under the station and into the storage, and from the storage sent up into the train station. Returning to the plastic facility, you can see that we've color coded the station, and we also have what will be the elevators all down with the resources running along a bus, ready for us to start working out the build and blocking it. However, for that, I do need to remove my train, which is in there, because that's blocking this whole thing from running. There we are. And here come all the resources. So now that we know all of the inputs are going to be at the end of this bus, we can start prepping the foundations for the build itself. And we're going to keep this really simple. I'm just going to place down a 5x5 concrete foundation block, and we're going to run this as a blueprint all the way across this section. We're going to need, what, 200 items, 200 buildables, so it's going to be quite big, and we'll start blocking it out once we've placed the first set, and if we need to expand it further, we can, or if we need to shrink it down, we can as well. And at this point, while you're building this out, you don't really need to worry about the size of it or the overall design. If you have a certain shape that you'd want to build with, then by all means outline the shape that you're going to be building. But for now, the important thing is just giving yourself plenty of space so that you can block out the facility. Okay, so we've got some foundations down that we can start to work with. Now I'm going to plan to have the output just over there. We don't need to worry about placing it for the time being, but we want to know the flow of resources. So the plan is that we flow from left to right towards that area. We want to now block the sections of the build with what they're going to be used for. And this is really beneficial because it gives us an idea as to how much space we have for each section. And we're going to start in the bottom here. And we know that in this section that we've got, we want to have 6 constructors that are going to take the limestone and turn that into concrete. So all I'm going to do is paint this area out so we know roughly how much space that we want for the constructors. I know that we can quite comfortably place them in here. So I've organized it and spread it out so that roughly we can see how everything is going to run. And we're starting at the very bottom here where we have the 270 limestone. So the next thing that we should do, we could either start planning out where we want the encased industrial beams, or we can start the next piece and go up. So here we've got 10 steel ingot foundries. So let's do that. And we're going to do the first section of each. So we'll have a smelter, we'll do the copper, and then the caterium and the silica. So for the steel, we're going to need 10 foundries. Let's go with 5 and 5. And we can actually, just very briefly, if we want to check, place these down. See, it pushes over ever so slightly. 4, 5. So actually we're going to need one more line. And we'll do that on both sides. So now we have the steel sorted. Iron is going to be really simple. It's just a single foundation. So we'll just place that there. Feels a bit silly just having a one foundation actually. So maybe we'll jump ahead to the coated, it's the coated iron plates, isn't it? So we need an assembler and a smelter. So let's have a assembler here, and we will also have a space here for the smelter. So the iron will come in here and into these. We only need 30 per minute. With that out of the way, we're now going to look at the copper ingot production. This is a big one. We're going to need 35. So we could probably do that, and we'll give ourselves a fair bit. Yeah, let's keep the 2 foundations of space in between. So looking at the copper ingot smeltery, we've got 2 lines, and I've already made sure that there's 600 on one line and 435 on the other. So we're going to want 20 smelters for one line, and then another 15 on another line. And I'm going to grab these and just see 1, 2, 3, 4, 5. Want probably another 12. 2, 3, 1, 2, 3. That's going to be our 20, and we will run the manifold along there. And you know what? We're going to separate the second part, and we're going to put another 15 here. It doesn't need to be perfect. We can gradually increase this if we need to. We just want to block the first set out and then work out where we want the resources to go for the next set. And what we'll probably do is a logistics floor, but I want to prep this out as you see currently before doing that. The next thing after the copper is going to be the plastic. That's going to be sent through the facility. I think we'll keep ourselves free here so that we have a little logistic line for our plastic, even though we're not using them just yet. Then up here, we want our caterium, and the caterium needs to be 6 smelters, followed by the quartz, which is going to be 4 constructors. And by blocking this out, it gives us a clear idea of the flow of resources. So for the encased industrial beams, we're going to need 2.5 assemblers. But before we do that, we're going to need 4 constructors to produce the steel beams. So what if we have the resources flowing down this line? We need about half the ingots to flow to a steel pipe setup, and we need the other half to flow to the constructors. So let's do 4 there for the constructors, and then I think, if I remember rightly, steel pipe is a 2-to-1 ratio, I want to say. So we have our steel beams and our steel pipes, and then we can have our encased industrial beams here. So for this one, let's keep it simple, and we're just going to set it up along this section here, and that should be enough for 3 assemblers, taking the concrete and also the steel beams. Hopefully you can see how transposing all of the information from Satisfactory tools onto the grid here gives us a clear layout to work with. And so from here, we'll start to build the facility on top of this. Now I'm going to just go ahead really quickly and transpose all the other sections, all the little setups onto this, and then we can quickly go over that. I think we are about there. So the last thing that I want to add in is going to be the computer section. We've actually got quite a few of these. We need a total of 12 computers, which is a bit of a squeeze even for this location. So what I'm going to do is start from the very end here, and we want to have, I think 5 might be, or maybe 6. And then we're going to go all the way along. We've got all of this space dedicated to being computers. And hopefully that'll be enough for all 12 of them. And after that, we will jump up and you can see the whole build. I've had to expand it a fair bit to make sure that we have enough room for everything, but we've got plenty of room. And this here is the layout that we've got. I'm very tempted to push the computers up too, and also the same with the high-speed connectors. And the reason that I do that is then it opens this whole lane here where the plastic is through there and into this area. So it gives us a nice amount of space for logistics. So what I plan to do with this build will be to have the underfloor logistics. Now I know that's quite difficult to see when it's a guide. So what I will do is I will do the build without the floor. So I will delete the whole floor where the constructors are so that you can see all of the logistics and how it all runs together. And then we'll just place the floor back underneath afterwards. But as you can see, the blocking makes it really clear what's going to go where, and it gives us clear sight lines for where we may want to run our logistics. And by making sure that we have a minimum of 1 foundation, or where possible 2 foundations space, it means that you're not going to have to worry too much about trying to run conveyors between different builds and not having enough space. So now that we're ready to start getting to work on the build, what I'm going to do is lift the floor up. For a logistics floor, we want at least 8 meters, ideally 10. So I'm going to build the actual facility on this floor. And the reason for this is if we cover this over, you can see that we've got plenty of space. We can add lighting if we want, and it doesn't feel cramped. And all I'm going to do now is build over a section. And then from here, we know that we're going to be doing on this little platform. In fact, what I'll do to make it easier for me with the different materials underneath is separate it. So this is just basic foundations for the time being. And we know that the top 3x3 grid here is going to be our concrete facility. So I'm going to start by building them, and we're going to place 3 on that side and 3 on this side. And then I'm going to do the logistics for this. So I'm going to add a splitter underneath. Normally you would do it up here, but because we're doing underfloor logistics to make it easier for us, we're going to place the splitter underneath, and then I'm going to use the floor holes, add our elevators, and connect this up. And I'll keep the signs here for the time being, and I can remove them afterwards. But the idea is that by having underfloor logistics, we're keeping all of this space clear, which makes the build really easy to walk around. And then if you want to place things like lighting above, you can quite easily. And then to give you an idea as to how this will look afterwards, I will delete the flooring and you'll see the logistics underneath. And then at the end of the build, I'll show you the whole build without the flooring, and then I will show you it with the flooring. So hopefully it's easy enough to understand if you're wanting to repeat this exact build yourself, as I know some of you are doing. So here we are with the first concrete section, and you can see how clean the top floor looks. And now I'm going to remove the floor. So hopefully you can see now how the facility's logistics will flow from one line to another. Anyway, I am now going to do all of this, and if there's anything I feel important to talk about at any point, then I will show you. The first section is done, which is fantastic. Notice how we've broken it into the compartments, like mentioned, into a single block. And one important tip when you are doing big builds is to make sure to test the system out before it's one whole system, just to make sure that everything is running. Any excess resources are going to be sunk, so that's going to be for the heavy modular frames. This is going to be for the excess steel pipes. That is for nothing. And that's all that's going to be in this section. And this is exactly why you should do this. This facility here hasn't turned on. Took me a while. I've just realized that I've just got the wrong recipe attached to it. But it would have been so much more difficult to work out if there were multiple problems and you're trying to run around to see what isn't working and where. Especially if all of this was housed over, then I wouldn't be able to see what resources were heading into there and why that was wrong. The other thing I should also mention, if you're wanting to trial the system and check the speeds, if you go to the awesome shop, you can go across, and since 1.1 under management, there's now the conveyor throughput monitor. And this is a new build piece which allows you to monitor how much is being produced per minute. It doesn't work so well on items that are only going through once or twice per minute. As you can see here, that's saying 6 per minute at the moment. But if it's a belt that is particularly full, such as say over here, and there you can see at the moment it is running at 33 per minute, and the intention is to have this running at 45. So we've just got to wait a little bit longer for this all to turn on. I think this is the last line that needs to fully turn on in order for them to run at full speed. Okay, so that's running at 45%, which means these two should be running now. So I'm happy to go ahead with the rest of the build. Now, as you can see, I have been making some progress with the Caterium and the copper section of the build, but we're now having to sort out wire and also circuit boards that require larger manifolds. And so the easiest way that you can do this when building a mega factory is to use blueprints. And in the past, when we've been building blueprints, maybe we've built a specific blueprint per part of the facility, and then we'd kind of patch them all together. Well, one thing to think about when setting up and planning out the factory is, rather than create dedicated blueprints for each section, to speed up the process, I recommend setting up a small blueprint that's going to be a manifold for you. It doesn't matter the recipe, just select what you're going to be using. So this one's just a constructor manifold. And then when building with these, we just need to make sure that they're in the right position. And in blueprint mode, we can quickly double these up. I've actually set this up the wrong way around. And then once we've done all of these, all we need to do for the next section, which is cable, is to go back over to our blueprint designer and just swap out all of these with the cable recipe, and then we can place them on the next section. You just save over. It's just a basic manifold. You're not trying to do anything fancy, and that's going to save you a lot of time from building individual blueprints, building up the manifolds, and will hopefully allow you to quickly build the facility so that you don't end up burning out from it taking so long. I also recommend doing the power with it, but because I want to talk about that at the end, we're going to do that separately, which I will no doubt regret. I already am. Just another really quick tip while we're here is that if you find that you've built almost a whole line, but you don't want to build over into the next layer because it's quite tight, it is perfectly fine to overclock one on each line by 100%. It's just going to use a bit more power. And certainly with bigger builds, it can be easier just to overclock. So you're reducing the overall amount of buildables that you need to place, even if that is going to use exponentially more power. As it stands, we're slowly getting there. We've got the computers, the supercomputers, the adaptive control units, smart wiring, and then the assembly director systems to all automate yet. But everything is turned on and working with the exception of the high-speed connectors. So I'm pretty happy with how this has gone so far. We will obviously clean it up as we go once everything's laid out, and I'm going to show you the total layout. And then after that, we will end up talking about the power. Okay, and here we have it. The facility is up and running and it's producing the resources that we've set it. Now, before we go on to talk about power logistics in Satisfactory and planning that out, I thought it would be best to break down the build. Now, we're going to do this in the individual sections because otherwise it's going to be quite a lot to take in, but you can also see the whole build here. So we will jump back to this at the end for you to look at. But after we've gone through this, we will cover the logistics floor so that everything will look a lot cleaner. Because though there is a lot of logistics going on at the moment, when we actually drop down, it's actually pretty clean. There are a few things that maybe we could improve on, but as you can see, there aren't that many lines going back and forth across the factory. It's only the necessary lines, keeping it relatively clean. And of course, once we've covered the floor, all of these areas are going to look really clean and easy to walk around. We don't really need to go down to the logistics floor unless there's an issue, but thankfully with the fail testing, we shouldn't need to. So let's break down the individual sections, starting off with the first part, and that is this section here. So in the bottom left-hand corner, we have our concrete, first and foremost, being produced from the 270 limestone, and that's going across to 6 constructors, producing 90 concrete per minute, which are then going across to the assemblers just to the right of that, which are producing the encased industrial beams with 2.5 assemblers running there. Now, those assemblers are also being fed by the steel beams, but to start that off, we should go ahead with the actual steel ingot foundry facility. So we have 10 foundries, with them running at 9 at 100% and 1 at 98.7%. And that's taking 449.423 coal. We've just rounded it up to 450 and 450 iron ore per minute to produce a total of 217 steel ingots going to the steel beam constructors, which we just mentioned. Those are running at 1.5% clock speed. So that's 3 running at 100% and 1 running at 61.5% clock speed, with 9.231 steel beams heading across to the steel screw constructors. That's to the right of that. We'll get to that in a moment. And then the other 3 sending 45 steel beams per minute to the assembler producing the encased industrial beams. Those encased industrial beams are then heading to the heavy modular frame manufacturers to the right of that. So we have 2 of them, and they're running at 150% clock speed. So that's 75% clock speed each. And they're also being fed by the steel screws, or at least 360 steel screws per minute from the constructors just above them. So that's 2 constructors running at 184.6% clock speed. And there's another 120 screws being split and heading up the top of the constructor setup and along to 2 assemblers just above the steel beams. And those 2 are producing the reinforced iron plates using the vanilla recipe, and both of those assemblers are running at 100% clock speed. However, to produce those reinforced iron plates, we also need to produce the iron plates. Those are being sent at 60 per minute from the single assembler running at 80% clock speed, combining 6 plastic and 30 iron per minute. And the smelter to the left of that is obviously producing the iron ingots. The other thing to bear in mind is we have 8 constructors running at 775% clock speed, producing steel pipes. And 50 of those pipes are heading down to the assembler section just below it to the right, producing the steeled modular frames. And each one of those assemblers are running at 100% clock speed. And we're also sending 60 steel pipes to the heavy modular frames and 45 steel pipes to the 3 assemblers to the right of the steeled framed assemblers, producing the stators at 100% clock speed. The steeled frame assemblers are also being fed by the reinforced iron plates, which is why they're running straight along into the steeled framed assembly line, and the modular frames that are being produced from there are going straight to the heavy modular frame manufacturers. And that is the first section done. Next, we have the copper section, which is at the bottom of this screen. You can see we have 35 smelters running at a combined speed of 3,449% clock speed. So that's essentially 20 smelters running at 100% clock speed on the bottom section and 15 on the top, being fed by 1,034 copper ore per minute. The lower section is sending 600 copper ingots to 4 lines of constructors. Each of those lines are 10 constructors long, producing a total of 1,200 wire per minute, with 1,080 of that wire running to the cable constructors to the right of it, which we'll get to shortly, and the other 120 being sent off to the assemblers producing the stators, which we saw a moment ago. In between the copper and the Caterium, we have our plastic logistics line. So for this build, we are using a total of 816.357 plastic per minute. So obviously it's not the full 900 that we're producing, but a good chunk of that. The assembler that you see in blue is producing our AI limiters. This is using the plastic AI limiter alternate recipe. It's running at 87.5% clock speed, and it's combining 24.5 plastic per minute with 105 quick wire, which we'll touch on shortly. Other than that, we also have 98 plastic on the lower bus. That is heading to the supercomputer manufacturers. We also have 480 plastic on the second line. That is heading over to our computer manufacturing line. And above that, we have 207.857 plastic per minute going to the Caterium circuit board assembler line, which is the set of blue assemblers that you can see just to the top right of the screen at the moment. And we'll touch on that shortly. But first, let's cover the Caterium. So this build uses 260.893 Caterium ore per minute, and these are being fed to 6 Caterium ingot smelters running at a combined 579.8% clock speed. All of the Caterium is being sent to the assemblers where they're combined with the 434.82 copper ingots from the second line to produce fused quick wire, and these are running 11 at 100% clock speed and 1 is running at 59.5% clock speed. We're then having 105 of the quick wire being sent down to the plastic AI limiter assembler, 315 quick wire being sent to the silicon high-speed connector at the top of the build, and we'll talk on the high-speed connector section shortly, and also 623.568 quick wire per minute going to our Caterium circuit board assembly line. Before we touch on that, we also have 78.75 quartz per minute being turned into silica by 4 constructors running at 350% clock speed. Next, let's touch on the assemblers producing those Caterium circuit boards. There are a total of 16 assemblers, and these are each running at 100% with the exception of one of them that is running at 162.9% clock speed. And these are sending 120 circuit boards per minute to the computer facility to the right of it, which we will soon touch on, 15 circuit boards to the adaptive control unit line, and 10.5 circuit boards per minute heading to the silicon high-speed connector line. Now, I am sorry, this is really wordy, all of this breakdown. Hopefully you find it useful. We'll also put some overlays over the top to make it easier for you to see everything. Before we talk about the manufacturers in the top, let's go back to our wired constructors in the bottom left of this. We have 120 wire, as we mentioned, heading to the stators, but the 1080 wire is being run to 2 lines of constructors producing cable. There's a 10 constructor line of cable and an 8 constructor line of cable. They're all running at 100% clock speed, with 240 cable running up to the computer manufacturer line, which is the set of 12 manufacturers just above the cable line. These are each running at 100% clock speed, and then above this we also have 4 manufacturers producing the high-speed connectors running at a combined 350% clock speed, and those high-speed connectors along with 14 of the computers are being sent to the supercomputer manufacturers, which are the set of manufacturers furthest to the right in the bottom right hand corner at the moment. It's just 2 manufacturers running at a combined clock speed of 186.7% clock speed, and we're splitting the supercomputers between our own storage but also the assembly director system, which we will see shortly. And the other thing to mention is just behind these we do have 3 manufacturers producing the adaptive control units, and that's taking 6 computers, 15 circuit boards, 3 modular frames per minute, and also 15 automated wiring. Now, the automated wiring are being produced in the assemblers below them. So there are 6 assemblers there running at 100% clock speed, and that's taking 300 of the cable per minute, as well as the 15 stators to produce. Now, with those adaptive control units and also 1.5 of the 3.5 supercomputers that we're producing per minute, we are producing the assembly director systems. Those are the 2 assemblers in the bottom right hand of the build, and they're running at 100% clock speed, allowing us to produce a total of 1.5 assembly director systems per minute. And obviously these can be slooped if you want, so you can produce double the amount. With this all up and running, the next thing for me to do is to actually strip out all of the power, and we're going to cover all of the production floor with the foundations, so that we have the logistics below and then the facility above. And then we're going to talk about power logistics in Satisfactory, because it can be really beneficial to think about this ideally before you start doing these builds, especially if you're tying them in with your blueprints as well. But it's something you definitely want to plan in advance, just to keep everything really clear and clean, because otherwise you'll end up having wires being slung across the whole of your facility, which maybe isn't something that you want. And here we are finally with the factory floor now placed. So it looks a lot cleaner. All the logistics are obviously below, as you can see from here, and it keeps it nice and clean. We don't need to go down on this floor, so there's no need to really worry about it, though we could add walkways if we wanted to. But we now need to think about power. And this is something really we should have thought about when we were doing our blueprints first of all and setting up the build. But I wanted to show you a before and after, and also to show you the whole layout of the factory. So forgive me for that, but we're going to talk about it now. As you can see in our starter factory, though we've tried to keep it quite neat and clean, power lines often just get in the way, and so it can be really beneficial if you are planning a big factory to think about how you're going to power everything whilst building. You could absolutely use power poles. It's the easiest way to go about it, and I try and keep them cleanly placed along the grid, so they're in the exact same position on each foundation. But more often than not, I will lift the power up using the wall outlets and placing them on these pillars. When it comes to refineries, as you've seen here, I like to daisy chain my setup by putting the power points inside the refineries. And it's these kinds of things that are worth bearing in mind when you're planning out and setting up your factory that will just help keep it clean and tidy, making it look like a nice build to walk around. So just to quickly show you for things like daisy chaining, what you do is you just grab a wall and then you could place this inside and you can then string these up along to other wall outlets placed like that. I've also known some people to just wire from underneath, just find a clean point to place them like that. That looks quite clean. But for me, I like to play around with the design and quite often do something that hides them. So for example, if we were to run this across here, I like having them directly on here, but I would consider grabbing a wall and then I would run that along here, and rather than use the dual PowerPoint, single PowerPoints, I would use the dual ones. And so we could connect these up along here and then on the inside run our longer wires. And this just keeps everything clean and tidy, and you can connect this with your blueprints so that you can do it really quickly as well. So I'm going to do that now, and then once it's all done, I'll show you the finished build. And finally, here we are with the power now sorted. And this factory is quite big, but the production floor looks really clean. Everything is running. Actually, there are a few things starting to turn on because I've just finished powering the computers and that side of the build, but it's getting up there. The yellow lights here are just because the buffers are full. But you can see how this has all come together to create a clean working factory, and it's by following all of the points that we've talked about today. And the last thing to mention is the final tip. Once you've done this, you can start focusing on the actual design of the facility, unless you're going for a build that focuses on design over function. But this, we're trying to produce X amount per minute. It's a function-based factory and it's now running. We can now start decorating, or we can leave it open. There's no need to decorate in Satisfactory unless you absolutely want to. Now we are going to leave it there for today. If you did like this video, do hit the thumbs up and let me know your favorite tip when it comes to planning. And also if you'd like me to do a planning guide to a mega factory, actually going into all the production lines and working it all out when we get to that stage, which will probably be once we finish the game, do let me know in the comments below. But until then, special thanks as always goes to all of our incredible supporters on Patreon, most notably our Totalxclipse patrons, Firefless, The Calamity, Ben and Star, and our Blood Moon of the day, which today is Papa Snoozy. But until next time, as always, ciao for now.